Good day. We're talking about motion, linear and motion, and then there are several terms we need to consider, such as distance, velocity. The velocity is in two. We have initial velocity and we have final velocity, and we'll be talking about acceleration too will be included together with time taken. So stay tuned as I show you an illustration. Right. Look at that white car. That white car is actually moving. The moment it stops, it has come to rest. It means that the final velocity is equal to 0 meter per second. Now he is about to move. So it means the initial velocity is 0 meter per second. The moment it moves, it now moves with a speed that varies. So in other words, when a car comes to rest, final velocity v is equal to 0 meter per second. When a car starts from rest, it means the initial velocity is equal to 0 meter per second. Accelerated motion. Now, most times when we get to the classroom, we find out they've written those three laws for us, and it's for us to memorize it, yes, and keep it upstairs. Every average student who is studying physics knows this formula. So I won't only be writing down the formulas. I'll be telling you how to derive those formulas so that once you know how to derive something, it sticks better than just looking at it and cramming it. You ask yourself, where did this stuff came from? Okay, so I want to tackle that issue right now. So I'm going to be telling us how we can derive those three equations before we dive into certain questions. Alright, the first thing is, from the video you saw initially, you discovered that a car starts from rest, or the car is already moving. Now, if the car is moving with an initial velocity, let's say u, and then comes to rest with a final velocity, let's say v. Now, for it to move, there needs to be acceleration. Alright? So, once there is acceleration, it moves together with time. So, there's going to be a final velocity. So, all these things set together, let's actually put it into a formula. So, what I said was this: acceleration is change in velocity over time. Change in velocity over time. So that will give us v minus u over t. And what I said initially was, if you see a car moving with initial velocity, let's say u, for the car to be moving, it means that the car is accelerating. Accelerating with what? With time. Accelerating with time. Acceleration is that's very, very better. That's like the car, you match it. Or if you're riding a bicycle, once you're paddling, that's what we call acceleration. It will definitely come to a final velocity v. So if you come here, it will now be ac equal v minus u. If we divide both sides by t, because our a is equal to v minus u over t. So this is the first equation of motion. Or you take it like this, or sorry about that. V equal u plus at. Any of the way you want to represent it, that is the first equation of motion. So, for simplicity's sake, I'm not to confuse. We're making use of this. Once the car is moving with initial velocity, when it's starting from rest or is already in motion, it is moving with acceleration with time, and it definitely gets the final destination is now the final velocity. So v is equals to u plus at. So this is
the first equation of motion. Now, the second equation of motion, let's say the car is moving already with initial velocity u, and then it now finally came to rest with another velocity v. So it means everything all together, we are having two velocities. Can we get now the average velocity? What's now the average velocity? Average velocity. We're talking about two velocities. That is u plus v over 2. I hope you know how average works. I can say I'm giving Tolu 4. I'm giving Amina 5. What's not the average? So 4 plus 5 divided by the number of items there, which is 2. So we are having two velocity u and v, and then the average is v plus u over 2. Now, from equation 1, do you see that v is equal to u plus 8? Why not? Let's change this v. Let's change everything about this v to this. So let's substitute equation 1 into this. So it's now giving us u, this is this u, plus, this is this plus. Instead of writing v, alright, u plus 8 over 2. Okay, so u plus u is what? 2u plus 80 over 2. Now, if I split this will give me, let me split it there. 2u over 2 plus 80 over 2. So this will cancel. What we're having is u plus r a t. That's not all. That's not all. So u plus r a t. That's not all. Now, average velocity, also, we also have a formula for average velocity, another formula for average velocity. So average velocity. What is the formula for velocity? Like standard velocity, like the one we know. It's actually displacement over time. So, let's call displacement s over time. Let's call it t. So if, let me explain. If a equals b and a equals c, can somebody tell me the relationship between b and c? It is b is equal to c. If a is equal to b and a is equal to c, automatically b is equal to c. So if average velocity equal u plus r80, and average velocity also is the same thing as s over t, it means s over t is equal to u plus r80. Now let's find s over 1, everything over 1, cross multiply. Now s equal u times t. Can you see? Or let me put it like this. Let me put it like this. T u plus r80. So now let me open the bracket. T times u is ut plus r80 squared. Now students are very fond of this mistake, and I don't want every student that's following this channel to make a mistake. Now, every student, some students will just tell you, they find the answer is s equals to ut plus r80. No. This t is multiplying everything there. It will be partial to give t to u and not give it to r80. Please take note. So it's better you put it in a bracket. So when you're opening the bracket, you know that t is going for u and it's also going for this. Please, that mistake is very common. When you have two variables separated by plus or minus, and something want to multiply them, they are one family. They are one family. This one brother, this another brother, and they want to share some toy, you can't give it to the first brother that I said. You have to give it to everyone. So it will be t times u equals to ut plus t times r80 is equals to r80 squared plus t times t is what? T squared. So this is now, let me box it. Let me box this. So that's the first equation. Now s equal ut plus r80 squared. This is the second equation of motion. Now let's go to the last one, which is the third equation of motion. So we're going to be making use of equation 1 and 2. Now let's start from 1. Let's square 1. Let's square everything. Now watch, because some students are also fond of doing this mistake. Now I want to square equation 1. Try and square it. I'm going to pause the video. Okay, I'm not going to pause the video. You pause the video and then try and square equation 1 and let's see what your answer is. Okay, 5, 4, 3, 2, 1. Welcome back. Are you having something like this? V squared equal u squared plus 8c squared. Are you having this? If you're having this, you are wrong. Very wrong. Very wrong. Okay, now let me show you how to do it. We want to square everything. It's going to be v squared equal u plus r80 squared. See, you need to be careful with things like this. I'm telling you, it can. And you know, from the beginning, if you're wrong, everything is wrong. So please take note. When you have an operator sign, either plus or minus, separating two things, and you want to find the square. You find the square all together. Not that you separate it, you square. No. That is mathematically wrong. And that was the same thing I was explaining here. So if what you're going to have is v squared equal to brackets u plus 8c all squared. So now let's find this. So this will give me b squared equal u plus 8c times u plus 8c. Please, it is like this. So let's multiply this. U times u square plus u8c, that's u times u square, u times 8c, u8c, 80 times u, also u8c, plus 80 times 8c is equals to 8c squared. So, plus this 2u8c plus a squared c squared. Now, I want to pay a very focus. We'll make use of equation 1, right? We don't want to make use of equation 2. I want you to look at this equation and look at equation 2. Are you seeing what I'm saying? Yeah, I'm seeing. I believe you're seeing what I'm saying. I'm seeing ut. Is there ut here? Yes, there is ut. I'm seeing 8c squared. Is there 8c squared here? I'm seeing a squared. I'm seeing c squared. But I'm seeing an extra a here. I'm not seeing an extra a here. I'm seeing 1 over 2 here. But I'm not seeing 1 over 2 here. I'm seeing 2a, but 2a is not here. Okay. Now, how do we resolve this complication? Okay. This is what we do. I'm dedicating this video on deriving equation of motion. Another video will be to solve questions. So let's do some later maths. I have PQ plus PS. And I'm asking you to factorize P out of them. So how do you factorize P? You factorize P, you say P equal Q plus S, right? Now when you factorize it, always check if, after simplifying this, I'm going to get what is okay. Let's say P times Q, PQ, P times S, PS. Oh, that's correct. So let's do another 4a plus 2a squared. And I'm saying to factorize 2a. Alright, 2a, that's simple. 2a now. If I take 2a from here, I'll be left with 2 plus, if I take 2a from here, I should be left with a. Alright, let me check if my answer is correct. Right. 2a times 2, 4a, 2a times a, 2a squared. Yeah, nice one. Okay, now let's go deeper. Let's say 2a plus p. And I said factorize a out. Oh, you're looking confused, right? You're saying you should factorize p here. There's p here, there is p here. That's simple. You say we should factorize 2a. I can see 2a here, I can see 2a here. That's simple. We are not telling you to factorize a out of 2a. That's quite alright. From p, there is no a here. How do I do that? Oh, it's very simple. Let me do this one. If I say factorize a, I'll be left with 2 plus. Yeah, I can see you nodding your head. Okay, what would you write there? Let me show you what I write there. P over a. Oh, check it out. A times 2 is 2a. A times p over a. This is what I'm doing. A will cancel a, I'll be left with p. Whoa. Yeah, that's true. That's true. Alright. I'll read that for the sake of this guy. Now, let's find out who are the stranger. We are having the stranger of 2a because I can see UT here. I'm seeing 2a here. So let's factorize 2a out and let's move on. Alright, if I factorize 2a out, I'll be left with UT. Now, let me show you something. When you're factorizing something out of something that, and that something is not there. So many something. Okay, I'm factorizing 2a out, fine, right? I'm factorizing a out, but a is not here. So the best thing is just put it over a. Oh, you're following. If I say you should factorize, if I give you q plus 4s, and I say you should factorize s out, so you write s. It's s here, you just write q over s plus. In fact, you can even just say 4s over s, and s will cancel s. I'm having s equal q over s plus 4. And then you want to put it. You can just say over p, and then bring out the p out. Do you see it? P will cancel this, p will cancel this. I'll be left with q plus s. So it does the same thing. I'll just put over s, and s cannot cancel anything up. So we're left with this. So you can use that method. So I'm going to use that same method. Alright, a squared plus t squared over 2a. So a, we cancel one of these a. Well, that I'll be left with b squared equal u squared plus 2a open bracket ut plus, I'm having over 2, that is 1 over 2. I'm left with 1a t squared. Alright, so having said that, oh, wow, interesting. Everything here in this bracket is s. Can you see it? Can you see what I'm saying? ut plus r 80 squared. Okay, so we are having b squared equal u squared plus 2as. So this is the third equation of motion. The first equation of motion, repeat after me. V equal u plus 80. Okay, I believe you said that. The second equation, s equal ut plus r80 squared. I believe you said that. And the last equation is v squared equal u squared plus 2as. Let's say it again. Final velocity equal initial velocity plus acceleration times time. The second equation says distance equal initial velocity times time plus half acceleration times time squared. And the last equation says final velocity squared equal initial velocity squared plus 2 times acceleration times distance. So these are the three equations of motion. But before I end this class, there are three key points. When I say three key points, we need to know when you solve this question. Key points. Please take note. The first key point: when a body starts from rest, u equal 0 meter per second. Second key point: when a body comes to rest, v equal 0 meter per second. And last one, when a body moves at constant velocity, acceleration equal 0 meter per second squared. Please and please take note of this key point. You're going to see it. So when you read the equation, the body starts from rest, just like one value is already given to you, which is u is equal to 0 meter per second. When a body comes to rest, final velocity is equal to 0. Now, I'm going to explain this. If your dad wants to take you to school, he enters the car, you are inside the car. Now, the car is not moving, the car is at rest. So it means that if you check the speedometer, there is nothing, everything that is really there is 0. So it means the initial velocity is what? 0. The car is not moving at all. Now when your dad is driving, and then he gets to the school, and then this gate opens, and he enters into the school, you know, he cannot drop. He has to off the car, like off the engine of the car. Like he has to turn it off. Now, the moment it's turning it off, it means you've got it to your final destination. It means the final velocity is equal to 0 meter per second. Now, I don't know if you can drive the car. If you cannot drive the car, you should be able to ride the bicycle. Now, if you're riding the bicycle and you stop paddling the bicycle, will the bicycle stop? No. The bicycle will keep moving, but it will be moving at a constant speed. It's moving at a constant speed. Because you stop paddling does not mean it will not move. Because your dad stopped matching the acceleration does not mean the car will not move. The car will be moving, but the car will not be moving fast. The car will not be moving slow. It's moving at a constant speed. So when something is moving at a constant speed or constant velocity, acceleration is equal to 0 meter per second. This 0 meter per second means riding the bicycle, you are not applying force to the pedal. Or if A is equal to 0 meter per second, it means your dad is not actually matching the acceleration. He is possibly taking his leg away from the acceleration. So that's why we have acceleration equal to 0 meter per second squared. It means the velocity is uniform. Look at it here. If I have A equals V minus U over T, and I say V is equals to U or U is equals to V, so what we'll be having is V minus V over T, which is 0 over T, which is equal to 0. So these are the 3 key points I want you to take note. and then right away we're going to start solving some question. See you in the next video.